right, today in geometry we are going to start chapter 7. Chapter 7.1 is the Pythagorean Theorem. This is not anything new for us, so this should be a nice, easy lesson. So we're going to start out with a right triangle. A right triangle has one right angle, which is equal to 90 degrees. And so there would be our right triangle. The hypotenuse is the side opposite of your right angle. So in this picture up here, this is my right angle. Directly across from that would be my hypotenuse. The other two sides of our right triangle are referred to as legs. So the Pythagorean theorem says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So this is our right angle. So a squared plus b squared equals c squared. Again, we already know this. Right, so we're going to start out with the notes. It says find the length of the hypotenuse of the right triangle. So in this case, the hypotenuse across from my right angle is my x. So I would say x squared equals 6 squared plus 8 squared. It does not matter the order that I put the legs in. So now I'm going to say x squared equals, so 6 squared is 36 plus 8 squared is 64. So then x squared, add 36 and 64 together, and we get 100. Take the square root of both sides, and I get x is equal to 10. So the length of the hypotenuse would be 10 units. So our next example, it says identify the unknown side as a leg or a hypotenuse, then find the unknown length. Be sure to leave all answers in simplest radical form. And again, I'm just going to add where our right angles are. So number 1, we notice that across from our right angle is the number 5. So we are looking for a leg. And so we're going to say x squared plus 3 squared equals 5 squared. Work this out. So x squared plus 9 equals 25. So x squared equals, so I want to subtract 9 from both sides. So 25 minus 9 gets me 16. The square root of both sides, and I get x is equal to 4. So I have, and again, this would be units. So I have a leg that's equal to 4 units. Example number 2, we are looking for a hypotenuse. So we would set this up x squared equals 4 squared plus 6 squared. So x squared equals 16 plus 36. So now we want to add these together. So we get x squared equals 52. The square root of both sides. This one is not a perfect square. It's a simplest radical form. So break 52 down. So I know that 2 goes in there. Let's see, 26 times. 26 breaks down to 2 and 13. I have a pair of 2's and a 13 left behind. So this time I get x equals 2 square roots of 13 units. And this is a hypotenuse that we found. So again, that's just using our Pythagorean theorem. Nothing new for us. We go to the next page. We're looking at a word problem. So Pythagorean theorem is famous for word problems. This is where it's very, very common and useful in the real world. So it says a 16-foot ladder rests against the side of the house. So let's draw us a picture. I'm going to draw, that's a beautiful house here. So here's my house. So a 16-foot ladder. Here's my ladder. I know it's 16 feet, so there's 16. The base of the ladder is 4 feet away. So this is the base of my ladder. This is 4 feet away from the house. Notice here that I have a vertical line and a horizontal line. I always know I get a right angle where those meet. Approximately how high above the ground is the ladder? So this is the side I'm looking for, which is a leg. So I'm going to say x squared equals 4 squared plus 16 squared. Or, sorry, I wrote that wrong. Let me erase that. So x squared plus 4 squared equals 16 squared, because the 16 is our hypotenuse. So here I have x squared plus 16 equals 256. We want to subtract 16 from both sides, so x squared equals 240. Take the square root of both sides. This is not a perfect square, but since it's a word problem and it says approximately, we want to go ahead and put that in our calculator. So x is approximately 15.4919, so approximately 15.5 feet above the ground. So our ladder is approximately 15.5 feet above the ground. Next, we're going to talk about finding the area of an isosceles triangle. Remember, an isosceles triangle means that it has two legs that are the same. So, and recall, area of a triangle is 1/2 the base times the height. So in this picture, it says find the area of the isosceles triangle with side lengths of 10 meters, 13 meters, and 13 meters. I know that the two legs are the same in an isosceles triangle, so those are both 13. This is 10. So if I use my formula, area equals 1/2 the base. The base of my triangle is not one of the legs, so that's 10. The height, we need to drop a height down, and then it makes a right triangle. The special thing about a height in an isosceles triangle, when I drop a height down, it cuts my base in half. So this becomes 5, and this becomes 5. So I need to find my height first. I'll actually call it h. I need to do that with the Pythagorean theorem. So I would have h squared plus 5 squared equals 13 squared. So I get h squared plus 25 equals 169. So h squared equals, so subtract 25 from both sides, and I get 144. Take the square root of both sides. This is a perfect square, so I get the height is 12. So now I'm coming back up here to my area formula, and I'm going to plug 12 in. So 1/2 the base. The base of the entire triangle is 10. The height of the entire triangle we just found to be 12. So multiply this together. So 1/2 of 10 times 12 is 120. 1/2 of 120 is 60. My units were meters. I found area, so I have to square those. So the area of this isosceles triangle is 60 square meters. So the next problem, find the area. Again, I see that it is an isosceles triangle because I have two legs of 26. So I'm going to say area equals 1/2. The base of the entire triangle is 20 times the height. I don't know that yet. I need to drop the height down, which cuts this in half, 10 and 10. So we need to find our height. So we come up here and find the height. So h squared plus 10 squared equals 26 squared. So h squared plus 100. So let me see, what is 26 squared? Is 676. So subtract 100 from both sides. So h squared is 576. When we take the square root of both sides, this is a perfect square. So the height of this triangle is 26. Oh, sorry. The square root of 576 is 24. So the height of this triangle is 24. So then I'm going to plug that back in up here to the area of the formula. So here, half of 20 is 10. So this is really 10 times 24. So my area is 240 square meters. Now we're going to talk about something special when we deal with Pythagorean theorem. And we're going to talk about a Pythagorean triple. So a Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Some common Pythagorean triples and their multiples. So this top row, if we memorize this top row, so it says 3, 4, 5, and then below it, it says 6, 8, 10, 9, 12, 15, 30, 40, 50, and then notice at the bottom it says 3x, 4x, 5x. So that means that x is the number that they all have in common. So 3 times what number gets me 6? 3 times 2. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. 3 times 3 gets me 9, 4 times 3 gets me 12, 5 times 3 gets me 15. 3 times 10 gets me 30. 4 times 10, 40. 5 times 10, 50. So all of these are also Pythagorean triples. Same thing here, 5, 12, 13. Its multiples, 10, 24, 26, 15, 36, 39, 50, 120, 130. And then going across, we see 8, 15, 17, 7, 24, 25, and all of their multiples. The nice thing about Pythagorean triples is if we memorize our triples, then we don't have to do Pythagorean theorem. You just have to remember that in a triple, your biggest number has to be the hypotenuse. So, for example, if I had a triangle that looked like this, and this was 3 and this was 5, this would not be a triple because my hypotenuse could not equal 4, because remember the hypotenuse has to be the longest leg in the triangle. So 3, 4, 5 is a triple, but not in this triangle since the 5 was a leg and not a hypotenuse. So in this next problem here, it says find the length of the missing side. I always check to see if it's a triple. So look, I have a 10 and a 24. If I go back to our list, 10, 24, 26, right? So, and I'm looking for my hypotenuse, so this is 26. I did a triple. So it's nice to memorize some of these triples. The most common ones are, again, back on this chart, the top row, the 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, and then also the second row, the 6, 8, 10, 10, 24, 26, 16, 30, 34, 14, 48, 50. All right, so now we're going to switch gears, and now they're going to give me 2 lengths of sides of a right triangle, and we have to find the length of the third side, and we have to determine whether it is a leg or a hypotenuse. Our trick here is our answer must be a whole number. Okay, so our answer must be a whole number. So we're trying to make a perfect square. So we can look first and do 20 squared plus 25 squared and see, is this going to give me a perfect square? So 20 squared is 400. 25 squared, I believe, is 625. I add those two together, and I would get 1025. And I'm looking for, is that a perfect square? This is not a perfect square, so I know that it's not a hypotenuse I'm looking for, so that means I'm looking for a leg. So that means 25 must be my hypotenuse. So then I'm going to do Pythagorean theorem. 20 squared plus, I'm just going to call it x squared equals 25 squared. So 400 plus x squared equals 625. Subtract 400 now. So I get 625 minus 400 gets us 225. This is a perfect square. So when we take the square root of 225, we get x equals 15. So we have the missing side of the triangle is 15, and it's a leg. So example number 2, 28 and 96. Again, okay, basically we're squaring both numbers. So if I square 28, I get 784. If I square 96, I get 9,216. I can try adding them together and see if I get a perfect square. So if I add those two together, I get 10,000. And I'm looking for, is that a perfect square? Well, that is a perfect square. So here I'm get the x is equal to 100. Since I added these two together, right, and 100 is bigger than 28 and 96, I found a hypotenuse. So when you are given two sides and you want to find the third side, you want to square both numbers that you're given and then add them together. Do you get a perfect square? If so, your answer is a hypotenuse. If not, then you need to subtract them and you will get a perfect square and your answer will be a leg. All right, so next it says find the length of the missing sides. Okay. I see that this is not a isosceles triangle because this side is 7, the side is 4 square roots of 2. So I do not know that this bottom was cut in half. So I'm going to have to do Pythagorean theorem several times. Okay. So first I'm going to call this y, And I need to do Pythagorean theorem to find y. So I have y squared plus 4 squared equals 4 square roots of 2. I have to square this whole side. So I get y squared plus 16 equals here. Remember, I have to square both of them. So I have y squared plus 16. 4 squared is 16. The square root of 2 squared, remember, they cancel each other out, and I'm just left with the radicand, 2. So I have y squared plus 16 equals 32. Subtract 16 from both sides, so I get y squared equals 16. Take the square root, so I get y is equal to 4. So this is 4. Now I need to do Pythagorean theorem again to find the x. So that's going to look like x squared plus 4 squared equals 7 squared. So I get x squared plus 16 equals 49. Subtract 16 from both sides. So I get x squared equals 33. Take the square root. That is not a perfect square. I factor tree 11 and 3. I don't have anything in common. So I get x is equal to the square root of 33. And y was equal to 4. All right, so that does it for our notes over the Pythagorean theorem. So we learned some new things in this lesson. We learned the Pythagorean triples. We learned how to find the missing side of a right triangle and determine if it's a leg or hypotenuse. And then we also reviewed how to find the area of an isosceles triangle. Remember that if the triangle is isosceles and you drop the height down, then it cuts your base in half. That wraps up section 7.1.